start setting up your integral for a graph like this? Where the two graphs intersect. So that's the number one thing, is figure out where the two graphs intersect. Let's go ahead and call this big one R1 and this one on the inside is R2. So it doesn't really matter what the equations are at the moment. So in order to find these 2 points are very critical. You're going to set R1 equal to R2 and solve for theta. So just as a strategy, when you're looking for area that has to do with two curves intersecting, you want to find where do those two curves equal each other, and then you solve for those thetas, and that's going to give you your interval. The other thing I keep recommending, which I hope you do on the test, draw a line from the origin through those points. So draw a ray from the origin through those 2 points, because that helps you to see how theta is growing and in what direction you want theta to grow. And I don't know if you remember from the quiz, you can look at your quiz, but these 2 angles ended up being what 2 angles? Does anyone remember what these 2 angles were in quadrant 2 and quadrant 3?
Wasn't it -2 pi over 3 and 4 pi over 3?
Well, this,
or for one of them it was.
This one is 4 pi over 3 in quadrant 3, and then this one is 2 pi over 3. Remember, the high angle is always the third, so like it goes 1/3, 2/3. This would be 3/3, 4/3, and then this angle here would be 5/3, and then 6/3. So if you're counting thirds, 1/3, 2/3, 3/3, 4/3, 5/3, and then 6/3 is back at the beginning. So there's my 2 pi thirds, my 4 pi thirds. And so now I'm going to do 4 different regions. So let's say the region I want, go ahead and kind of shade it in with your pencil. Let's say the region I'm interested in is not the region on the quiz. Let's say I want to find the area of that region. So I want to find the area of this blue region that's outside of the smaller circle and inside this limacon. Thoughts of how we're going to capture that area, and what interval should we go from? Because you can only go counterclockwise, so remember, to go in the positive direction, you can only go counterclockwise. So the only way I can capture that area is to go counterclockwise from this ray to this ray. But am I going to go from 4 pi thirds to 2 pi thirds? Is that what I'm going to do on my interval, Jalo? Change the 4 pi thirds to y. So why does 4 pi thirds to 2 pi thirds not work? No, you're right with the -2 pi thirds, because you can also call this one, instead of calling it positive 4 pi thirds, you can call it -2 pi thirds, because that's what the angle would be if I went backwards from 0. Can anyone explain why I can't go from 4 pi thirds to 2 pi thirds? Why is that not okay? Isaiah?
The area going backwards, so it'd be a small angle.
Yeah, it'd be trying to go the other direction on the other side of the circle. And a rule of thumb is I can only go from a small angle to a big angle. So you know you're doing it wrong if you're going from a big angle to a small angle. That means you're trying to go backwards. That's not good. You want to go from a small angle to a big angle. So I need to figure out what small angle this is equivalent to. So I'm going from small to big. That means I'm going in order, counterclockwise around the circle. So it's going to be, do we remember the formula for the area? What has to be in the front? 1/2, and then now I know my integral is going from -2 pi thirds to 2 pi thirds. And then now talk to me, how do we capture just the blue part? How do we capture just the blue part? Porter?
Do R1 minus the part of the circle, it's like R2 and a little bit of R1.
He's got the right idea. He's saying R1 minus the R2. Is there something missing from his formula? Is set up? The squared. So is it R1 minus R2 quantity squared? What is it?
R1 squared.
Minus R2 squared. Very good. So it's the area of R1, which is 1/2 R1 squared, minus the area of R2, which is 1/2 R2 squared. So it's the big area minus the little area. And that gives you this outside area. And the way you know that is if you draw lines, like if it helps you to draw these lines, when you draw these lines, you can see that the radius of the big one minus the radius of the little one is gonna get you the blue. So the radius of the big one minus the radius of the little one is gonna leave behind the blue, which is what you want. That's why this works. Okay, so if it helps, you can draw the little rays, and that shows you what area you're capturing. All right, so let's try another one. Let's try, and on the quiz, it was funny, because people did like different unique ways of setting them up, and I wanna talk about, I think, the most efficient way on the quiz. But anyways, let's do, so how about this one? How about I want this little area, so shade that in. Again, put in your rays. Here's ray 1, here's ray 2, here's R1, here's R2. So label everything again. What should these rays be now? Should it still be the negative 2 pi thirds and the 2 pi thirds? What should it be now, Leland?
It should be 2 pi thirds to 4 pi thirds.
Very good, because now I'm trying to go counterclockwise. I always want to go forward, which is counterclockwise. And so I want to go from small to big, and now this is small to big. This is good. I'm going from 2 pi thirds to 4 pi thirds. So how do I get this little blue thing? Again, think of the rays. If you draw your little rays, how do I capture just the blue part that I want? I'm going to call on someone from the cup. What should I do to get just this little blue sliver? Did I not talk to yet? How about Samantha? What do you think should go in the integral?
R2 squared minus R1 squared.
So now it's R2 squared minus R1 squared because, and how do you know it goes in that order on this side, Samantha?
This is the R2's on the outside. It's further away.
It's further away. That's exactly right. You're looking at how the further it goes, the bigger the area. So the further away, the outer curve is going to be the outside one or the first one. So this time it's R2 squared minus R1 squared. And if it helps you, you could write right here, this is the outer radius minus the inner radius. So it's not top, bottom. It's not left, right, like we used to do with area. It's outer, inner. And that's the same here. This was the outer and the inner. And it switches. When you're on this side, it's a different outer on that than it is on that side. Okay? All right, let's do another one. Flip to the back. So outer, inner. All right, so how about same labels? Draw your little radii in. So bam, bam, and that's always going to define your interval, no matter which area you're looking for. And let's say this time I want to find this area right here. And that brings us to the quiz, because that's part of the area we were interested in on the quiz. So here's R1, here's R2. So now again, are we doing 2 pi thirds to 4 pi thirds or negative 2 pi thirds to 2 pi thirds? Which one are we doing if we're on that side of the shape?
2 pi thirds.
That's right, now, because we're still going counterclockwise. So we're doing 2 pi thirds to 4 pi thirds. So you can set that up, 1/2 integral 2 pi thirds to 4 pi thirds. And then, what am I finding now? So I'm gonna call someone from the cup. I only want the blue shaded area. So think about it, if I draw my little rays, I have to stop when the area stops. So if you draw all your little radii out to the boundary of that area, what does it take to find that area? Let me see. How about Jonah? What do you think?
The outer part is the R1 on the end, but then I'm not sure what
The outer part is R2. Do you mean this?
Yeah, I was saying that.
This is yes, I agree. So the outer, I'm hitting the R1, I agree. Am I
Yeah.
ever hitting R2?
Not really, I mean, you're in it, but not like.
I'm in it, but I'm not hitting it. My radius that I'm looking for has nothing to do with the radius of R2.
Yeah, it's more like the Y line, like the,
Y,
I don't,
Y line?
I don't know how you do it.
Like this line?
Yeah, like it's the vert or whatever you call those like lines, like, I don't know.
These, okay. So do you agree that in order to capture the blue area, I only need to hit R1?
Yeah,
So my area is gonna be 1/2, 2/3, 4 5/3 of what? What goes in here?
R1 squared.
That's it. It has nothing to do with R2, does that make sense?
Yeah, I thought it had something to do with those, like, the lines that you drew, like.
The lines that I drew are just the interval, it's just the boundary.
Okay.
So the lines that I drew are just telling you that my inner roll is gonna have this interval.
Okay.
Cause it's like swinging, think of it like a swing that's going shoo, like that.
Yeah.
And so it's capturing the area as it swings past that space. We feel the difference? So on the quiz, some of you didn't do that. Some of you did like, you found the outside sliver and then subtracted it from the whole circle, which is cool. That's all cool, but you could have just literally done this to find that part of the area on the quiz. It's just the area from 2 5/3 to 4 5/3 of just the R1, because that's the only part I care about. So now last one, now shade in. Draw your little rays again, because those are the starting and stopping points of all of these integrals. So we'll decide if it's 2 5/3 or 4 5/3, but now shade in this part. Let's say I want this part. So you notice we've kind of isolated 4 different sections of this graph that we're interested in, and they all have a different way of finding the area. So now what do you think? I'm over on this side, am I doing 2 5/3 to 4 5/3 or negative 2 5/3 to 2 5/3? Because now I'm on the right side, and to get onto that right side, I need to go counterclockwise, and the only way to go counterclockwise and capture that area is to go this direction, which means I have to go from a lower angle than that. So this has to be the negative 2 5/3. So now it's negative 2 5/3 to 2 5/3. Here's my 1/2. We'll set up our little integral. And then again, if it helps, draw the rays. Like I'm trying to capture this, I'm trying to capture this, I'm trying to capture this, and I'm capturing it in a fan. It's not going left to right, it's not going up or down, it's going around in a fan. It's sweeping around like this. So, what's my integral? An integral of what? Let me call on someone. How about Brody? What am I taking the integral of now?
R2 squared.
That's it. Why is R1 not part of my integral?
That's on the outside.
That's on the outside. This area has nothing to do with that curve. When I'm on this side of the graph, this blue area has nothing to do with R1. It's hitting R2, 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 R2. I want the area inside of R2. So on the quiz, several of you figured out, I just need to do this plus this. This is what you had to do on the quiz, because on the quiz we wanted these 2 blue areas together, but you had to have 2 separate integrals to find it. And we knew that once we drew in the rays, we could see, oh, on this side I'm hitting R2, on this side I'm hitting R1, or vice versa. And so that's why I had to put those together to get my total area. Okay? Any questions about how each space is different? And how the interval changes? Any questions about that? So that should help you figure out the problems on the test. So that's a good thing to study. All right, now we're gonna do a game.